First of all, I want to thank everybody for taking time out of their busy schedule to view this webinar. We've had some very, very, very good feedback from it over the years. Obviously, we've tried to enhance it, bring it more current as time has evolved. And again, I hope that you enjoyed it. What we find is that a lot of times people don't just view it once, because Howard does present quite a bit of very technical information. We find that people will actually come back and view the webinar multiple times to try to pick and choose some of the information to better understand it. For those of you who don't know me, my name is Jason Spangler. I am the flooring division manager here at Wagner Meters. I'm responsible for not only the Rapid RH side, or the concrete moisture testing side, but I'm also responsible for the small line of wood hand meters that we have for testing the moisture content of wood, finished wood products, and wood subfloors. And we're going to go through a Q&A section, so if at any point you guys have questions, please email them to me so that I can try to answer as many of them as possible while we're videotaping. If for some reason you do think of questions after the fact, please don't hesitate to call us, because that's what we're here for. My direct line is 800-634-9961, and my extension is 235. So without any further ado, let's get to the first question. Julia has a question. Will this webinar be placed on YouTube after, or can you email me a video to share with my coworkers? I'm actually glad you brought that up, because I always forget to actually mention this. As far as sending you this exact webinar link or being able to view it outside the context of the scheduled times, no, we can't give you the whole thing in its context the way it is. But with that being said, we have a webinar that has much of the content that is here, and it's actually on a website that can be viewed on demand. The website is aiaspec.com, and all you have to do is sign up. It will ask for AIA credentials, but if you don't have any, you just put no in there, and then you can view it on demand. So whether it's a coworker, whether it's you guys have some AIA specifiers, whether we're talking, you know, the actual specifiers or architects, they do have the ability to get CU credits if you have any clients that are out there that fit that parameter. One of the other questions I get a lot about revolves around slab thickness. One of the things you probably picked up on when Howard was doing his presentation is that relative humidity testing is based on a very, very depth-specific measurement. And in order to get the best information, it's critical to try to calculate and to set the sensors at that 40% if it's drying from one side, or 20% if it's drying from two sides, depth in the slab. And so when you have a slab on grade, I have people asking, well, how do I know the slab thickness? Well, one, if you're talking new construction documents. If you're talking rehab, obviously you have trenching, site superintendents for both. So just being able to kind of be inquisitive about that question really does make getting the answers easier. Now, that being said, we all know that even if with the best specifications, that things are not going to be consistent from, you know, straight across the board. And so what you'll find is that sometimes people will actually take a smaller diameter drill bit, and in a couple of locations on the slab, they'll actually drill all the way through the slab. And what they'll do at that point is they'll typically take some wire, they'll make a J-hook out of it, and they'll make the top opening of the J just a little bit bigger than the diameter of the hole, so that when they push it down, it compresses it. And as they push it all the way down, that J will spring out at the bottom, so that when you pull it up, there's resistance, so that you know that you're attached or stuck on the bottom of the slab. At that point, take a Sharpie, mark it at the surface of the concrete, pull it all the way out, and you can look at the Sharpie mark, and then the general radius of where the J was at, and you get a pretty good idea of what you're looking at from a thickness standpoint. I'll have people that tell me, well, you know, what about drilling all the way through? You're compromising the vapor retarder, and, you know, comments like that. One, I mean, people do it. I would say that if a couple of holes from somebody drilling all the way through is the worst thing that ever happens to that vapor retarder during the placement and construction process, that vapor retarder has done extremely well. What you'll find is that people will take that hole, they'll usually fill it with epoxy or something along that lines that's injectable, so that you can actually fill it, fills the whole thing in, and there's never a problem. The other question I get regarding thickness is if I have an elevated slab that's in pan decking, where do I drill? I have areas that are possibly, in fact, I just got off the phone, areas that are 3 inches in the shallow part, and they're 6 inches in the deep part, and they're every 6 inches where you have that alternating thickness. Where do I drill? What thickness do I drill? First thing I always have to say is that, unfortunately, right now, the ASTM standard is completely silent on this specific question. And we really do look to that ASTM standard as our basis for guidance to the general end user out there. That being said, we have to look at what the science is behind relative humidity testing. So we look at a slab in pan decking is only drying from one side. So at least a given we know at this point is that whatever thickness we decide to drill or calculate based on, it's going to be based on 40% thickness of that overall slab thickness. But you have people that do it a couple different ways. One is they will try to identify manually where the thickest portion of that slab is. And what they'll do is they'll either take a smaller diameter drill bit and try to drill until they hit metal so that they can actually identify where that deep section is. And then a lot of times they'll measure off of that to possibly set placement of their additional sensors, or sometimes they'll take smaller diameter and they'll just, every time they drill a hole, they'll actually try to identify that deepest section. Once they have that deepest section, then calculate whatever, if it's a 6 inch, like I was talking about with my phone call, 6 inch thickness, 40% of that, 2.4 inches into the slab, drill into it, and that's what you do. Again, that's one way that people do it. The other way that people do it is there are actually some fairly inexpensive metal detector types of products that are out there that work a lot like stud finders for walls, that you can scan across the surface. You can identify where the high spots are, so you find a shallow here, and you drill right in the middle of them. It's not perfect because there's a lot of things in there that can cause interference, so it's not going to be an absolute, but some people do use that. Now, the one thing I didn't mention about the slab on grade also is the fact that they have devices that are out there that you can actually use, and they use what they call echo impact principle, and it's a device that you can hold on to, put it on the surface of the concrete. It connects to an iPad or some type of smart device, and it will help you to identify the overall thickness without having to actually structurally drill into the concrete. Downside to it is when you're looking at a situation where you maybe don't do it a lot, or you're not going to use it a lot, the price tag on it's about $2,500 last time I checked. So for a lot of people, it's a little bit outside the realm of realistic to have as a device to have for day-to-day use. So looks like I have another question here. It comes from Bernard. What about a structural concrete slab exposed to the air on both sides? Is it still 40%? No, again, that's what the two parameters of relative humidity testing are. If you have a slab that is on grade, or in essence, any slab that's only drying from one surface, you're going to drill 40% of the overall thickness of the slab. If you have a slab that's elevated and drying from both sides, so you have airflow across both the top and the bottom, then you're only looking at 20% of the overall thickness of that slab. In essence, what you find is that the drying curve on a slab that's drying from one side, it kind of has a gradual less moisture at the top, more moisture at the bottom as it goes down. When you have one that's drying from two sides, you see that same curve, but once it gets to the middle, it starts to come back around. So it's almost like a U-shaped drying curve, so that you have some reasonable consistency. If the environmental conditions above and below are comparable, you start to see the moisture gradient within the slab from top to bottom becomes fairly consistent. So it looks like I don't have any other questions. Again, my name is Jason. My direct phone number is 800-634-9961, extension 235. And if you have any questions at all, now or in the future, please don't hesitate to give us a call. Thanks, and have a great day.